Tan delta test, often called the power factor, is a test where you measure the insulation of your either transformer, power transformer, also voltage or current transformer, or even a circuit breaker can be also tested with this function. Tan delta, the simplest way how to explain it is that we generate high voltage up to 12 kilovolt, and it's an AC test, it's important to mention, and the current which is being generated by this voltage has a certain phase angle in respect to the voltage which created it. We are measuring that phase angle and trying to get what is the tangents delta of this angle. Once this test can be done in few ways. So here you can see first of all that you can do only a single shot, which means let's say 60 Hertz and 10 kilovolt. But if you get a result which is not satisfactory, you can do something which is a sweep, a voltage sweep, or a frequency sweep, which gives you much better idea if this device is really okay or not. Is this insulation good or is it compromised? One of the reasons this is so is because that sometimes on higher voltages or higher frequencies, water which is kind of hidden in the transformer insulation's paper, not always, very often, most of it's in paper, can be seen only if you do a sweep. When you do a test, you will get many information, many results, let's say. First, we will know what is the actual voltage generated, what's the frequency generated, what is the desired voltage and frequency, and then you will get the actual voltage which was generated. This is always a few volts different, but we guarantee with the accuracy of 0.2 the voltage generation, and the accuracy of tan delta is 0.05. Output current is also noted. Usually, if you measure tan delta, you will find milliamps, few milliamps maybe here. Capacitance is the value which is kind of proportional to tan delta or power factor, which are actually the values we're looking for. Often people just look at the capacitance. And then we have a few information here, like what would be the amount, what is the resistor connected in parallel to this capacitance, here, because we are modeling right now the insulation as a parallel condensator capacitor in parallel connected with a resistor. You see a lot of more information. So if you were to test a circuit breaker for tan delta, you would be looking at this information here. What are the actual losses? And you can also see the impedance, the actual inductance and the actual impedance. And this is basically the place where he tells you how much is the angle you measured different than 90. You can also get the apparent power and, the reactive and the apparent power and some other information. Tan delta in the end can give you also the results in a graphical form, whether if you were to decide to generate from 2.5 until let's say 12 kilovolt, you will see the capacitance and you want to see the capacitance not change. Tan delta or power factor need to change slightly, but if they change, for example, like this, then you obviously have a problem with your insulation. So also one thing to mention, this device has the ability to test tan delta with any kind of mode. Is it a GST, which is a ground specimen test, or is it an ungrounded specimen test, or is it a grounded specimen test guarded? And the booster for generation of 12 kilovolt has two input, so you can test power transformers which have primary, secondary and tertiary, which is not possible with, if I'm not mistaken, double devices.